Hello class, today we will discuss isometric view problem. The given two views is front view and top view, and the origin is mentioned towards left for front view, and this is the origin for top view. So as per the origin positions class, your front view will lie on right plane. Okay. So class, first we will draw a cuboid which have right plane dimension equal to 110 mm. 65 plus 15 plus 15 plus 15 is equal to 110. So this dimension is class 110, height 50 mm, 50 mm, and the width is 50 mm. So this is 50 mm. So this is the cuboid class 110 mm, height 50, and left plane dimension is 50. Now first we will class read the given two views. So see class, here start from this side. Okay. So now class, in front view this dimension is equal to what class? 15. So this 15, this flat surface 15 mm dimension projection is visible in top view class, this rectangle box. Now class, in top view this rectangle box is the projection of this non-iso line, and class this rectangle box is the projection of this flat surface. Then after that class, in top view there is one more rectangle box. This is the projection of class this flat surface. Now class, this rectangle box is the projection of this non-iso line, and now class this rectangle box is the projection of this flat surface, and this hidden line in top view is the projection of this circular shape. That's mean class, this surface and this surface is class non-isoline surface, and class this surface and this surface is the non-isoline surface. Okay. So now class, whenever we start drawing class, always see the origin position. So class, see in front view this is the origin position. So class, this is the origin position 2. The dimension, the origin dimensions class will start from O to this side. So we will move from origin to back side. Okay, like this. So 47.5 we will mark on this right plane. Okay. So now class, let's start. Again class, we will first mark non-isoline projection, because class for non-isolines we required starting point of line and end point of line reference. Let's start with class. So class, in front view this is 10 and 40. So class, just mark 10 and 40. This is 10, in class this is 40. Okay, this line. Now class, we know in top view it is 50 mm. So this is 50 mm. 50 mm. And now class, the thickness, the dimension of this surface is class 15. So now measure 15 mm dark, and join to this rectangle box is nothing but the projection of this top view box. Okay, now class we will draw this height. This height is nothing but class 40 downward. Extend class this point vertical downward. Okay, so this is class 40 and this is this corner point. Okay, now class again we will draw this much distance, that is equal to what class? 15. Okay, now class we reached to this point class. Okay, and now class this we will draw complete dark. So this is my base, complete dark. Now class we need to draw this flat surface because this is the starting point of non-iso line for this side and this side also. So we'll draw class for this 35 mm flat surface in top view. Okay, and the position of this flat surface midpoint is class 47.5 from origin. So class from origin measure 47.5 . So class this is the 47.5 projection. Now class from this point draw a vertical line, construction line, light in shade. Okay, now class we got this point over the right plane axis. Now class from this point we need to mark 35. So now class suppose this is that the projection of vertical line 47.5. Now we will mark class 35 half both side. What is the 35 half class? It is 17.5. Plus measure 17.5 both side. $17.5 17 okay, so this is class a line of 35 mm dimension. 35 mm dimension. Now class in top view we know it is 50 mm dimension. See class this rectangle box. Now class we will extend these endpoints back side parallel with left plane axis. Okay. Okay, now we drawn class this 35. Now class we will draw this non-isoline. The starting point of our isoline class, end point of this 35 mm line, and your end point of this isoline is class, and this 15 mm line end point. So starting point of 35 and end point of 15 mm line. So now class join these 2 points, you will get this non-isoline. Okay. Similarly class we need to find out this endpoint of this non-isoline, which is class at a height of 10, and this distance is 15. 10, 15. So class from here first measure 10 vertical up, then 15 down right hand side. First mark class 10 mm. Then measure class 15 mm. Now join this end point with this corner point. So this is class your this non-isoline. Okay. Now class we need to draw this non-isoline. The starting point of this non-isoline class we already drawn. This is the starting point of this non-isoline. Now class we need to find out the end point of this non-isoline, which is at a height of 20. Okay. So class from this corner point draw vertical up 20 mm. Now class draw this part. Okay, 20 mm, and the class width, the dimension of width of this non-isoline plane is class 25. So from here measure 25 mm. Okay, heading class 20 mm height, then in top view 25 width, 20 mm height, then 25 width. So now class, this is the starting point of non-isoline and this is the end point of non-isoline. Starting point of non-isoline and end point of non-isoline. So class, we will join these points right now, light in shade. Okay, light in shade. Similarly class, from this end point class, we will draw a slope of this non-isoline, light in shade. From here class measure 25. This is the 25. So now class draw projection of non-isoline, light in shade. Okay, so these two lines are class the projection of non-isoline. Okay, now class we need to find out the intersection point of two non-isoline, this point class, where this non-isoline is intersecting with this non-isoline. That point class we need to find out. So class, okay, so now class first complete this part, extend Okay. Similarly, class, right now, just extend class this point towards left, parallel with this x-axis, light and shade. So class, first take projection of 15 mm from this side. Okay. So now class, when we extend class this point towards right depth and we'll extend class this point towards left depth, then we will get class one intersection point. Okay. So now class, that distance is class how much? 25 mm. That distance is class 25 mm, and this distance is also 25 mm, and total is 50. So class, this point, that point is your class this point. Getting class? This point is your this point. Now class, from here measure 25 mm on that line. Okay. Now class, draw a non-iso line, light shade. Okay. Getting class? So now class, this non-iso line projection when intersect this non-iso line, that point is class this, where this non-isoline projection is intersecting with this non-isoline projection. That point is nothing but class this point. Getting class? Non-isoline projection of this non-slope is intersecting with this non-isoline slope. That point is nothing but class this point. Now dark below part, dark class this edge. Now dark class this edge also, and class dark this edge also. Okay. Now we will draw class this edge. Now class, we will draw this edge. So class, okay. Now class, join this point with this, and now class dark. Okay. So this is class your plane of this non-isoline, and this is the plane of this non-isoline. Okay. Now class dark the slope like this. Okay, now class, from that point class, draw vertical line downward, and class from that corner point class, draw a edge parallel with left plane axis. Okay, now class, the only remaining part is class this circular shape which have a diameter of 30 mm. Okay, but and the height of the circular part is class 30 from the base. Okay, so now class, on the projection of a vertical line at a distance of 47.5, on that vertical line class, first mark 30 mm. That 30 mm is nothing but class center position of circle. Okay, so now class, in isometric, to draw a circle we need to draw a rhombus. Okay, so we will draw a rhombus which have dimension equal to 30. Okay, so class, first we will mark 15, 15. Okay, now class we will draw 15, 15. Similarly class here 15, 15. Now class, join the longer diagonal of the rhombus first, light in shade, then class from the shorter diagonal corner point join other side midpoint. Now class, complete the circular shape. Okay, class, this is your required ellipse. Okay, now class, we will draw, this is your front side. So class, this is your complete solution.